Hello, my name is Newby, and today I'm going to be talking about something I've been around almost my entire life, baseball bats. Even though I've played baseball for years, I realized it didn't actually understand how metal bats are made or what they're made of. So for this project, I decided to explore the two main categories of bats, alloy bats and composite bats. Alloy bats are mostly made from aluminum, but they can also include metals like zinc, magnesium, or copper. Composite bats, on the other hand, are made of non-metals such as carbon fiber, graphite, and fiberglass. These two types of bats perform very differently. Composite bats usually have a larger sweet spot and make more of a thud sound. Alloy bats have a smaller sweet spot and make a ping sound instead. Stronger or bigger players often use composite bats because they tend to be heavier. Smaller players or players who want a lighter swing usually pick alloy bats. Since I play on the club baseball team, I thought this project was the perfect chance to dive deeper into how bats work and maybe even get more interested in the engineering behind them. Now let's talk about performance differences. Alloy bats are made from aluminum-based blends, which makes them durable and consistent. Most alloy bats are one solid piece, so they feel stiffer and transfer energy more directly into the ball. Manufacturers can also make their barrel walls thinner, which increases the sweet spot and improves what's called the trampoline effect. This effect is basically how much the bat flexes and springs back when the ball hits it, which increases batted ball speed. Alloy bats work at full performance right away, no break-in needed. Composite bats are different on the other hand. They use reinforced carbon fiber polymers and are usually made in two or three pieces. This design reduces vibration, increases flexibility, and improves energy transfer, giving the bat a smoother feel. Composite bats also have an even stronger trampoline effect because they act like a spring. However, they need a break-in period, so the resin inside the bat can loosen and allow the fibers to move more effectively. Material properties also affect how the bat swings. Composite bats often have lighter barrel ends, which decreases their moment of inertia. This makes the bat easier to control and helps players swing faster. That's why many young players or contact hitters choose composites. But because these performance differences can get extreme, organizations like the NCAA and USA Baseball place limits on bat performance to make sure the game stays safe. Now moving to structure. Alloy bats usually use 7000 series aluminum, like 7075 T6. These alloys have a face-centered cubic crystal structure that lets them stay strong while still being formable. During processing, tiny particles form inside the metal and block the movement of dislocations, basically making the bat stronger. But defects like small cracks or pores created during manufacturing can reduce the bat's overall fatigue life. Composite bats have a different structure altogether. They're made from layers of carbon fibers surrounded by a hardened epoxy resin. The fibers have aligned graphene planes, which makes them extremely strong along their length. But defects like fiber misalignment or delamination can weaken the bat because they interrupt load transfer between fibers and the resin. Microstructure plays a huge role as well. Alloy bats have fine aluminum grains and precipitates that increase strength and toughness. Composite bats have a layered structure where the orientation of each fiber layer is carefully controlled to optimize stiffness, reduce vibration, and improve energy return. Next is properties. Alloy bats get their strength from the precipitates inside the aluminum, which helps stop deformation when the ball hits. Composite bats get their strength from the carbon fibers themselves, which have very high tensile strength. Composite bats are also much better at absorbing vibrations thanks to the polymer matrix that naturally dissipates energy. Alloy bats don't absorb vibrations as well, so manufacturers sometimes add foam or other dampening systems to make them more comfortable. The elasticity of each material affects the trampoline effect. Aluminum is stiff but still flexible enough to rebound the ball well. Composite bats can be engineered with different stiffness in different directions, letting manufacturers fine-tune performance and energy return. Finally, let's talk about processing. Alloy bats start as melted aluminum that gets cast into billets. These billets are heated and pushed through a die to form long tubes. The tubes are then stretched to thin the walls and achieve the right weight and feel. After shaping, the bat is heat treated to increase the strength, then CNC machined to get the correct dimensions. Some alloy bats also get foam inserts to reduce vibration before they are painted and gripped. Composite bats are processed completely differently. They start with a mandrel shaped like the inside of a bat. Carbon fiber sheets are wrapped around the mandrel in specific directions to create strength where it's needed most. The wrapped layers are heated in an autoclave, where heat and pressure harden the resin and bond everything together. Once the bat cures, the mandrel is removed, the outside is sanded, and grips and end caps are added. Extra internal layers may be included, increase power, or reduce vibration. In the end, even though alloy and composite bats may look similar, they are made from completely different materials with very different structures and processing methods. And these differences are exactly what create the performance variations players feel on the field. Understanding how these bats are made has given me a much deeper appreciation for the engineering behind the sport I love, and maybe even a new interest in pursuing engineering in the future. Thank you.